My dear students, today we will be discussing the chapter Earth's structure. In this chapter, we get to learn about the interior of the Earth or the Earth's surface that we talk about. That is, what do we see inside the Earth? But this is a concern because it still is a mystery and there is no such direct sources that help us understand the interior part of the Earth. But there are obviously indirect sources that helps us to understand that what do we find or how the Earth's interior looks like. So the indirect sources are temperature, pressure, density, the earthquake behavior and volcanic activities. Through these indirect sources, one can make out that the Earth's interior may be the thing or maybe the conditions what we are about to learn or study. So in this case, let us first discuss about the three indirect sources that we have, that is temperature, pressure and density. Temperature, as we all know, it's a degree of hotness or coldness of an object. So in the Earth's interior, all these three, in fact, are not just the temperature, but pressure and density as well, they keep increasing as we go towards the inner part of the Earth. The temperature also increases at the rate of 1 degree centigrade for every 32 meters of descent. That means as we go deep inside the Earth's surface, for every 32 meters, the temperature increases by 1 degree centigrade. So with this rate of increase, what we find is at 48 kilometers depth, that is within the crust, the temperature is somewhere around 1200 degrees centigrade. Well, as we move to the innermost part of the Earth, the temperature seems to be rising very high and it reaches somewhere around 400 degree centigrade. The pressure likewise it increases, though we must have studied that pressure and temperature is inversely related, but here what we see is the temperature is increasing, but at the same time the pressure is also increasing because of the overlying layers. We see we are on the Earth's surface, or we can say that the crust where we stand is the outermost layer, but there are layers beneath this crust which feels the pressure of this overlying crust on them. So that is the reason why the pressure keeps on increasing as we move towards the interior part of the Earth's surface. So at the innermost part of the Earth's interior, in fact, the pressure is somewhere around 3.5 million atmosphere. At the rate with 1 atmospheric unit, if it is 14.7 lbs per inch square, then what we find is the core will have 3.5 million atmospheric pressure. While density, as it also increases with depth, the reason why density increases with depth is because the interior part of the Earth is mostly made up of heavy materials. The outermost part of the Earth is made up of lighter materials, so hence the density is less. But the innermost part is made up of higher density, it is made up of heavier materials resulting to increase in density. So what we see here is, on an average, the whole of the Earth has a density of 5.5, but as we see, the density keeps on increasing. On the upper layer, it's 2.7 to 3, then towards the innermost part, that is in the core, we'll find the density increasing up till 15. And this is how we see that the Earth's interior can be determined with the help of the indirect sources. Now further, we'll be discussing about the three different layers of the Earth's interior. So on the basis of the sources that discussed earlier, the Earth's interior is classified, or you can say is divided into three different layers. The uppermost layer is known as crust, the intermediate layer is mantle, and then the innermost part is known as the core. So let us discuss them, each one of it. The crust, which is also known as lithosphere, the word lithosphere is derived from a Greek word lithos, which means rock. So that means the uppermost part of the Earth's interior, that is crust, is mostly made up of rocks. It stretches to almost 48 kilometers deep inside the Earth from the surface where we stand. It is divided into two different layers, mostly known as continental crust and the oceanic crust. The oceanic crust is the land under the ocean waters, while the continental crust is the land surface where we stand. So this crustal part is further again classified on the basis of the chemical composition as Cl and Sima, the two layers. The upper layer is known as the Cl, which even we discuss as the continental crust, while the Sima is the lower layer, which we can discuss as the oceanic crust. So Cl and Sima, as on the basis of the chemical composition, Si stands for silicon and Al, the upper part of the crust, stands for aluminium, whose density is approximately 2.7, while the inner part, that is the lower part of the crust, is known as Sima because of its chemical composition made up of silicon and magnesium. It's a little heavier material and hence it is located at the lower portion of the crust. Its density is also a little higher as compared to Sima. Its density is 2.9 to 3. The Cl is mostly composed of granite rocks, while Sima, since it is deep inside the Earth's crust, is mostly made up of basaltic rocks, which are of mostly volcanic origin. The crust is separated by the mantle with a discontinuity, as since it's a discontinuous layer, it is separated by the Mohorovičić discontinuity, or you can even say Moho. Once again, the crust is separated by a Mohorovičić discontinuity, or you can also call it Moho, with the mantle. So the mantle, now here we see it's the second or intermediate layer next to the Earth's crust. Usually when we see volcanic activities taking place, the molten magma that comes out of the Earth's interior on the surface is from the layer of mantle. Its density is approximately 3 to 5 and depth until 2900 kilometers. The mantle is also separated into two layers, the upper mantle, which is mostly in liquid form and is known as asthenosphere, while the lower mantle, mesosphere, because of the overlying pressure and heavier materials, is mostly in the solid state. The mantle is mostly composed of magnesium and silicon, but there are also few traces of nickel and iron, the heavier material, at the lower portion of the mantle. While the third layer is the core, and it's the innermost layer of the Earth's interior, which is also known as barosphere. Its density is 12 to 15 and its composition mostly made up of heavy materials like nickel and ferrous, that is iron, and hence it is also known as a layer of knife, N-I-F-E. Ni stands for nickel and Fe stands for ferrous. The core mostly is in its solid state because of high temperature conditions and pressure. It is mostly found in the solid state, while the core is also divided into two layers. It's known as the outer core and the inner core. The density of the inner core is higher than that of the outer core. So this is all about the chapter. Class, I hope you made it clear with the points that have been discussed. You'll have a good day and take care. Thank you.